Thank you, everyone. Thank you for being here today. Today, the topic will focus on many use cases, but within one domain. That is manufacturing. That is the team that I'm with, US Manufacturing from Microsoft. I am an architect with extensive background in data science and data mining. Applied that to a few domains in the past. Including healthcare, including job shop scheduling in grad school as well and after, nuclear power plant, a few others. Anybody here in this room from Centene, by the way, my past employer? Nice to meet you. We'll talk after, hopefully. Welcome. Anyone from Monsanto, now Bayer? Yeah, that was my past employer as well, great places. Now I call St. Louis home since I moved here and joined Monsanto, and after that Centene, and now Microsoft. Before that I lived in we should call it windy city to Boston. What to me was very, very windy. Rain and snow comes this way. So and there's no bad weather, there's only bad outfit. Just so you know. All right, so today I'll walk you through all the technologies behind the work that we do most in US manufacturing. The coverage is the entire US, but the companies themselves could be global companies. And some of the use cases may have been applied to a plant somewhere else, not just inside US. We have NDA, so some of the data that show more generic that, maybe not specific to my customer per se, but you get the idea. For the high level down, I will also walk you through, from my opinion, two kinds of AI that I see often in manufacturing use cases, and we talk about those, and also we'll pinpoint to the use case that we are here today, the work that we did, my team and I did at MIT during late December actually, unfortunately. So I may not have a lot of Christmas or holiday breaks last year, so poor me. We did some work with the mechanical engineering over there, graduate school there. They have sessions that they offer for smart manufacturing with enterprises to come and learn about IoT, about how to get data from these machines, how to get insights from these machines, but they are mechanical engineering, so they are not data scientists, and we came in to help them. And first thing I spot was, you want to maybe detect, two kinds of the production that you have in your plant floor in MIT lab. And I suggested them, we could do two ways: predictive maintenance using telemetry data that they have sensors read the, velocity and temperature and whatnot. Or we could do something that I usually do now, and I have a lot of respect to this technology now too. It's called custom vision, which is an AI vision to do classification, basically. I built a bunch of other apps afterwards for fun, and I'll show with you after this too with a demo. But for MIT itself, it kind of underscores the difficulty of the domain that is fiber optic. Fiber optic, imagine, is just a thin line, right? Thin line, very kind of transparent too. And in order to detect a good thin line from a bad thin line, don't ask me, I don't know it. And I point a camera on my phone onto the image, and train with a handful amount of images. One group is good, one group is bad, and then save some images not to use for training and use for validation, and found the accuracy to be pretty good, and you will see that yourself today. And a lot of manufacturing customers use that to detect dings, scratches, water drops on their things that not supposed to have any water, things that are very, very small and very subtle, not just, at the booth, maybe you visit us at the booth downstairs, not just facial expression or gender or age anymore. So I'm pretty impressed by this technology so much. So let's start our journey together today for the time that we have. AI in manufacturing. When it comes to data science perspective in smart manufacturing, to me, right, from my lens, it's all about AI. But AI isn't really the only thing there to make smart manufacturing smart. It's mobile, it's IoT, it's connected field services, where field service person at your door, say, to fix your washing machine, for example. He has all the things that he needs. He hooks his computer to your washing machine and, get the data from that. So that's the kind of idea of smart manufacturing. But he can also retrieve, other information or consult the expert. Maybe he's not, been in a job for too long and he hasn't seen that situation yet, and consult expert online through virtual reality, where HoloLens or things like that. So all of this is not fiction anymore, it's real. Mobile, IoT and all that come together to help manufacturing to be smarter and be what we call manufacturing 4.0 to enable that to happen. In this session, we'll focus on just the things that we can cover in a limited time that we have, just the AI and things around AI. But manufacturing organizations use AI to engage with customers nowadays. They also use AI to empower their employees, to optimize their time, their KPI. I have a use case that a worker talks to AI, so conversational AI, where Bluetooth headset, and asks, how am I doing today? What is my performance per hour today? How many packing boxes I've done per hour? What's my best last month? And the bot talks back and encourage. Or maybe today, I don't want to, beat my best today. I'm a little bit tired. Last night I didn't sleep a lot. Let's play some music, things like that. So that's possible now with conversational and with AI behind it. Also make work environment safer. We are working today with a customer that has a forklift. And if you go YouTube forklift, you will see a lot of accidents that like all the shelves just fall. You cannot believe it. It's so many of those videos. But in this use case, just to detect, how far a worker around this forklift, or whether a forklift going to nick something or drag something that it should not, and use Kinect sensor to detect that, and to help improve safety, help improve posture of a worker when they lift things. Don't use the back to lift things, for example, and that's alert. These things are possible. Reduce waste and downtime. That's one of the use cases I will walk through today as well that we did at US Manufacturing. And the last one, transforming products. A lot of manufacturing today do not just sell their products, but they'll sell the uptime of the product, and that's possible too. Change from the product to service model, just like cloud. Instead of selling you the software, I sell you the usage of the cloud, same idea. And these are the core four kind of pieces that work well together. Let's just pick one up, like edge, for example. Do you understand edge computing? Should I talk a little bit about it? Because it's kind of between, right? It's on-prem with you edge, just the name. So basically it's to offload some of the cloud capabilities, subset of the cloud capabilities to this device next to you on premise. In this case, in our case today, manufacturing within the four walls of the plant floor. And I'm asked a lot and often by my customers that, can we do this within four walls? Because some of the things I cannot let go because I am a contractor of a government entity, for example. So this requirements is more often than not. And these are cloud customers, right? And so we need to meet that requirement in order to, service our customer the best. And what's the benefits of having edge versus cloud? Not all the time that manufacturing plant area will have the best internet. They built this maybe long time ago, many years ago, right? Because we're one of the first, civilized country to have industrial, and some of those machines still being used today. Many years ago, and the investment was great. And so having edge computing and not having internet, because the internet bolt on instead of built in. So that helps with the latency, help with the connectivity that would need only from time to time, not all the time. So those are some of the features that Edge is here and has a place to be here today. We'll look more at the architecture of a manufacturing plant later, and you will see the complexity of the work that we do. Next to Edge is cloud, right, and IoT. Remember I mentioned about the new way of selling products, selling service instead, product as a service. IoT makes products become services because we can now monitor with the sensor, we can get the telemetry data, we can know the data, and then that's not going to be enough. Data rich information has to be rich too. So we get the insights from those data and selling the uptime so that we know as the company that sells that service, we know when to go maintain that uptime again and again. Otherwise, you're going to have to pay penalty for SLA, right? Service level agreement. Some other use cases of IoT, and this one is not too far and not fiction, but maybe a little fatigue. I'll move out of manufacturing a little bit. Suppose I push a shopping cart in a grocery store with IoT sensor, and it knows, I log in, it knows that it's me. I'm a member of this, chain. And when I walk through to this aisle, and it say, hey, that one for you, there's a deal, And it's a little fatiguey, a lot of alerts and all that. So it's not just engineering and science that would be enough in this case, right? And in manufacturing too, change management is important. People fear of losing their jobs using IT and AI. So change management should be there and has to be there. People who understand behaviors and modify behaviors to be to fit with the technology, to fit with the behaviors rather, has to be there to help for this implementation to be a success. These are some of the major customers and success stories that we have at Microsoft. I bet that our friends at the booth downstairs, Microsoft booth downstairs, could talk a lot about some of these cases, such as ThyssenKrupp, the elevator uptime there, predictive maintenance, and others. But let me hone in on one that is JBuild down here, just to walk you through because it's closer to our use cases in Vision. So JBuild is one of the Vision AI use cases, earlier ones, maybe 3 years ago already implemented by a team of data scientists at Microsoft. And it was, the AI was built from scratch, which I will, the two kinds of AI that I'll walk you through later, I call it DIY AI, do-it-yourself AI, versus pre-built AI. Microsoft did a predictive maintenance project at JBuild to enable point-in-time defect detection. Why is that important? Can we inspect the failure and defects at the end? Yes, you can. But in case of JBuild, it's very costly. They produce circuit boards. And circuit boards themselves are already costly, right, for computers and for other control systems. And once you stitch a CPU chip on it, it's even costlier. And if that stitch is wrong, the soldering of the wires and whatnot is wrong, you better call it out and push it out of the process right now because the whole thing is a waste. Do not stitch the next thing, memory and whatnot on. So that's the kind of idea that, the line of process, assembly process, if you can detect that once it happened, you reduces a lot of scraps and waste. Let's see a short video here. 2 minutes, 2:30.
At JBuild, we're privileged to serve 250 of the best brands on the planet. We provide ideation services, design services, manufacturing services. We architect and orchestrate some of the most complex supply chains around the globe.
Some of the main challenges we're facing today is how the consumer mindset has drifted into all aspects of the company. People want things flexible, they want it customized, they want it quicker, and our systems have to be able to service everybody from automotive to healthcare.
We're dealing a lot with mass customization, decreasing product life cycles, and the need to provide more and more data to our customers.
From a JBuild perspective, we are transitioning from reactive to predictive tools to prevent risk and increase velocity.
We're really focused on how is it that we can do everything that we do more effectively, leveraging digital type technology.
As we start looking to what we think the challenges are going to be going forward, both what we want to do in the cloud and what we want to do on-prem, the Azure platform seemed to be the best fit for us on trying to mix those two worlds together.
Our engagement with Microsoft enabled us to do some exciting things in predictive analytics and trying to understand how we can become much more proactive in our management of our manufacturing processes.
Often we are data rich and information poor. So we can take the data from our manufacturing, we incorporated data from our supply chain and data from the field, and we can put that into our modeling. We can create some sophisticated models that allows us to predict defects and provide very good feedback to our customers on how to improve designs and improve the customer experience with the product.
We're working diligently to marry the data points from a reactive to a predictive mindset. So we're taking millions of data points and putting them into what's called the iFactory manufacturing suite. That's our new generation of shop floor control in the corporation. It integrates end-to-end production in all of our factories for the first time in the history of our group. The ability to exercise the tool both here in our facilities, in our DCs, and jump out to the cloud and back and forth is just unbeatable.
The predictive analytics, the use of iFactory, the integration of Microsoft Azure just helps us deliver that much faster, that much more efficient to ensure that when our customers, consumers receive that product, that it's a great experience.
I may have quoted the guy there because I listened to that quite a few times. So this is not quite an architecture for like cloud or on-prem. It's just a kind of workflow to show you about JBuild work. AOI, you know what AOI is? Automated optical inspection. That's a lot of manufacturers, automotive, anyone that has to do with electrical use that a lot to inspect. A lot of times they use infrared type camera, heat camera too, and they have experts, trained eyes at the end. And how fast can you do that if you were that expert, right? And how many of this you're gonna need to look at every 8-hour shift. Right, you're gonna get fatigued and you might make mistakes or you might make a call that close, right? So if we could pipe some easier or repeated tasks to AI, to machine, to software to do it, and send just the tasks that very, very difficult, just require expert human, then that would help improve the KPI and production so much. And we'll be happy to talk more about that use case offline and at the booth as well. So the next topic is two kinds of AI in my mind that I've seen in manufacturing. One first type is do-it-yourself AI, write code or Python and etc. More language than I could learn in data science. So the next one is pre-built AI, which is actually the core of the demo downstairs where you walk to that big TV with a camera. That one do facial recognition, age, sentiment, whether you smile, you're happy or sad, or other pre-built AI about voice, text, speech too. I'll walk you through some of those. But let's focus on the one that you need to write code. These are some of the use cases that I've seen more often than not. In manufacturing, quality assurance, demand forecasting, right? Manufacturing cares about demand, yes. It's not just production, right? It's the whole line of sight. Production scheduling, and the two that I see most often in the red box, anomaly detection and predictive maintenance. And that's what I hone in more often because our role, my role, such as a solution architect, and some friends here are architects too, we there to help them understand and actually have a chance to touch and see the system working for them through our POC work. And so in order to grab some concept easily, the red box anomaly detection and predictive maintenance seem to relate very well. I see more about supply chain and invention optimization and talk to a conference attendee just now at the break about optimization. I've seen a large global company process manufacturing. There's discrete and there's process. Did you know that? If you want to apply to my team, you got to answer this question right. What's process manufacturing? Process manufacturing produce like liquid and mix and with recipe and things about paint, or other type that you have to have a recipe. And they use, and so when they make one type of product, chemical or say, things to spray on plant, for example, whether that for growth or to prevent insect herbicide or whatnot. If you wash the machine off, the next thing that you produce may have some residue. Would that be okay for the next thing? If that's okay, let's produce that next thing and then wash again so that the downtime is minimized. How to organize all these products to be made by this same machine differently. And so this one is being used with a new idea of deep learning and also reinforcement learning as well. And it's very interesting. It's something, that very cutting edge and something I'm learning as well too. Some other use cases that help you imagine more, such as detect dings from that box. We use for milk and for juice all the time, and that's unacceptable. We will not pick that one from the refrigerator, from the grocery store, right, because there's a ding. Video monitoring, this is real. I've seen use case in our partner ecosystem, and this partner helped with Hershey Twizzler, save them a lot of money in mixing the color and the ingredients into Twizzler, and use predictive maintenance to do that. But now they do video monitoring for a plant that does the paper mill. And if paper has a little wrinkle, the AI vision will circle and identify the area. And so and paper mill feeds really fast too, and that's pretty amazing in my opinion. My team build a control system for temperature in the household, speak to that control system. And also a partner ecosystem also build this for some home improvement company to help customer detect. So I have a leaky faucet. Take a picture. I know it's one brand, but I don't know what SKU I bought from Home Depot versus Lowe's, and these are all different. Some from Lowe's have one grade, some from Home Depot have another grade, some made of plastic, painted to look like metal and things like that. And so in order to help them identify just the right part to get service, use cell phone to help detect that. And lights, contrast, right, all these affect the accuracy. And this is my the use case when I started with this team 2 years ago. Joined force with the customer themselves and also a partner to do predictive maintenance. In my lens, it's always simpler because to me, I'm a data person, so data lens. Ingest the data, right? Clean the data, and that's the tough part. You have to work closely with data owners so that you don't do anything stupid, basically. And understand the data, build yourself to feel like you are in the data. That's the first step. That's really hard for me. But other than that, the modeling part, the prediction part, the test and train, evaluate, these are all the workflow that data scientists who hold the sexiest job on the planet right now know how to do this, and visualization, right? And for this one, actually, it's a global company. They want to do predictive maintenance on this saw cutting machine with a saw. And once you do something like that, rubbing something on something, there's wear and tear, there's heat, right? And there's dullness. And the massive material that they're gonna push through this machine. And I've seen that, and it's just huge, bigger than the video that I'll play later. That's video is generated. But if the saw blade stuck in that thing, and that material costs $1 million in itself, to remove it is very difficult or impossible or really dangerous. So how do we know to maintain the machine, the saw cutting, the engine around it, oil and whatnot, coolant around it, so that it will cut through this block until the end within my shift, 8-hour shift. So we align all this together. And if by the end of my shift, this blade is not good enough for the whole shift, next shift, I better replace. It's my job to replace now. So that the downtime align with the breaks and the switch of people too. So let's take a look, just kind of get the idea of, and this considered super small comparing to the real use case. You see the water there needs to cool. Some signals are better to detect failure than others. Acoustic is very good. Heat is very good. Vibration. the carriage, return of the motor, very good too. And the speed. Speed can be fast, can be slow, and it will show the dullness of the blade as well. So that's pretty fascinating to have worked on that one for me personally. So let's go closer to our use case, Vision AI that we did at MIT, which we use Prepare.ai. Custom Vision is a part of Cognitive Services at Microsoft. We built this using cloud scale compute and a massive amount of data so that, the models will be generic and adaptable to your domain. The model downstairs is the generic one that do facial recognition, age, sentiment, and have the collection of, the timeline and plot that. But we can customize that models to match with your domain just using a handful amount of images from your domain, which I did. Typically 30, 50 images to start with to do classification, good and defect, for example. So 30 to 50 good, 30 to 50 bad. The trick is that you use the real situation image. If you have bad contrast, you use those images. If you have shadow, you use those images. Do not use catalog marketing kind of images. Those will not work because in real life you take a real picture and then it doesn't understand anymore. The philosophy behind cognitive services is that it must be easy to use, small amount of your own data to customize it. Must be flexible, can be deployed in my phone, Android, or any web internet connected machine, or actually edge with no internet connection for a period of time. And other platform as well, built with the best of breed from Microsoft research. And along the way, we also contribute back to the open source community to, for example, build this Onyx collaboration ecosystem partnership to standardize deep learning, deep neural networks that you export out to run on these other platforms. And I, again, welcome you to visit us at the booth to try just a glimpse of the Vision API. And application can be to help blind or part of vision folks to explain the environment. That would work too. And other thing that we did, like the distribution center packing, we use all of this speech, language, knowledge, and search to talk to the person and encourage him or her to pack faster, or check whether if he wants to improve the day, improve the productivity and the quality of life of the worker at the same time. I will not go through all these use cases, but like to have here and also in the slide that I share with the conference too, so that you have something to maybe spark your ideas about the technology that within reach today. No code, no AI coding, no deep learning, no TensorFlow writing. You just submit the domain data, whether that be voice, acoustic, or others, or in this case, pictures, images. And this one, it would describe the crowd, objects around it, whether it's busy, walking, city scene, that kind of thing. I will go through architecture real quick because I like to really go to the demo that I have on my phone to show you about the fiber optic. But these are the architecture on the plant floor that we usually have. You probably know MES, CRM, and things like that. The resource planning, ERP, the blue icons, boxes, those are what Microsoft have the expertise to provide to customer in manufacturing and work well together with those systems. But not all systems are Microsoft, of course, right? And this is my view of the architecture that's kind of cleaner than just the first one, blue and green, in terms of things, right? When we talk about IoT and edge and cloud, things and pipe the data in, ingest the data in to get the insights. And these are the tools that we use, and then take action. And we can even send the action back to the machine, to the sensor to adjust and fine-tune and do self-healing at the same time too. And if you don't have anything to take away out of this session today, this would be something I'd like you to have as a high-level, from manufacturing and other application things, insights, and action. Now, the fun part, the best for last, fiber optic. The true fiber optic manufacturing is a 3-4 story high plant situation. Imagine fiber optic, just a thin line, but actually you need a lot of that thin line to, say, for your internet company locally to install in your city. How many miles of that you have to produce, and how, control our situation so that it will produce exactly or guarantee the amount of speed that you need to deliver. And now we watch, Amazon, Netflix, and all the video streaming. All this infrastructure is really crucial to our everyday life. And orchestration of this is massive. So the MIT mechanical engineering team built a smaller version, much smaller version that is nimble, that is adaptive, that is for R&D and engineering, so that they can introduce new ideas, new material, new ways to produce this, how to heat it so that it's more flexible, how to cool it faster so that it's not sticky anymore and will not be a bad fiber. So they published a paper in 2017 about this work. And they also done a collaboration with started since Obama was in office with 3 main sectors in collaboration. Education has MIT, Carnegie Mellon, Michigan, Georgia Tech, so on and so forth. Industry has Dow Chemical, has Ford, and many others. Government has NIST, Institute of Science and Technology, DOE, and many more to build this correlation. The left top one is my favorite, flexible, stretchable, for electronic circuit to wear. So that's pretty cool stuff. And the model that they built, and we will see that in a video today, has all this part, similar to other manufacturing, has wear and tear, has water cooling, has speed, some thing to roll, mortar and spool to roll this fiber. And as you can see, right, that's the line that I need to detect correctly most of the time, more than incorrectly. So that's my job. And this is a lab at MIT over there. It's true because of that and that. Have you been in engineering before? That's the line, right? And this is very clean. And the line is on the left where the pointer is, and the background is just a sheet of paper. And there's happened to be a wrinkle on that too. So my model has to understand that, get rid of the wrinkle. And the line is tiny. And the middle machine there has lab view running on Windows, of course, to kind of change the settings so that this one we know is good, this one we know is bad. And the right black surface machine hooked up to the camera here. That is, in this case, a Raspberry Pi camera kit around a Raspberry Pi. Is a tiny cheap thing, very cheap. It's not industrial grade. I'm not recommending this to go production, but for this purpose, it works well and connect to that machine to predict as edge. And these are the 2 types of good and bad lines. The good ones thinner, the bad ones thicker. That's it. And there's wrinkle there, or maybe a water drop. So let's go show you. And I also built an app that can be used with a web browser or a mobile phone. Let me pull that up. So, all right, I call it Fiber app. I also built a fender bender app. That's one. Take a picture of your car, and it's not fender bender, yes. It works, unfortunately, for my friend who had a fender bender. So this app, right, I don't have a cable. I can take a picture too, but that's nonsense, right? So I loaded some of the stock picture that I didn't use for training or testing, for training at all. Let's do bad operation. Let's do that one, and hopefully it returned back. So now it connects to the internet, to the web service, and call back. And all this color and things, that's just what I built. bad operation with the confidence 99%. Let's try a picture. But whatever it is you know that it's not true because it's not cable. Okay, it's not fiber optic cable, I mean. Very bad, yeah, I would say so. So that's the kind of idea with a handful of images, a few iterations with the lab. At first, they gave me picture that's so far away with a metal table and a metal lamp so big, and it wouldn't learn anything. Or in our case in general, when you take a picture and build some use case, just that your shadow might be the biggest object because you take a picture and the sun is behind you, for example. So that will not work. So some of these recommendations we have, how to make your model a little better, to customize the scenarios from your pictures a little better. And this is the actual...
And we have just a couple minutes left, so...
Yeah. Just to show the real-time prediction, a lot of times it doesn't have a clear-cut decision. It just picks one higher than the other. You see good operation, 28% confidence, bad operation, 6%, and that connects through the lab view back to the machine there. So you get the idea. And I would like to encourage you to follow through some of this, if not all. CustomVision.ai is the website that you can try it out, this technology out basically, and you can try it for free. Sign up with Azure credits or MSDN. If you in academia, you have MSDN for sure. Yeah, and check out our booth downstairs for intelligent kiosks. You want to take a picture of that? Yeah.
Great. Well, we're running just a couple minutes over, so maybe we could take one question, and if anybody needs to head on to the next session, you can do that. But any questions? Yeah.
So I was wondering if so it seemed like a lot of these applications were using like CPU machine learning algorithms. So I was wondering if you've ever come across something that you needed to use a GPU machine learning algorithm to get a lot more processors on your classification or other aspects of it?
Definitely. The behind the scene, especially for DIY, the write your own code, need to have GPU to process. And behind the scene for the pre-built one, definitely built from GPU. But once it's done, wrapped around, exported as an Onyx or Python Pickle, right, model, it doesn't need GPU anymore because it doesn't do the training. Training is the heavy part. So CPU or edge computing like that would work too. Yeah, basically GPU is required in cognitive, in sound, in videos, in we can smell, machine can smell, sorry, in vision, because the amount of the data. Let's talk about vision. Like from a phone nowadays, 4 megapixel is already bad phone. You don't want to use that, but it's a lot for deep learning, right? I just talked to you about it. 4 million pixels. Each pixel store 3 colors, so that multiplied by 3, and each color is at least 8 bits, and that's not true, 64 bits. You multiply all these numbers, you get many, many millions. And let's say you do 2 pictures, exclusive or them. You already exploded my surface. So so GPU is required, and a lot of technique to reduce that, capture the signals versus noise is required too. Yeah.
Great. Well, for the sake of time, I think if you are heading out to another session, I want to make sure that we have that. But if you want to stick around and ask Kay some more questions, please do so. Thank you again, Kay.
Thank you.